Hello viewers, welcome to the introductory lecture of microwave. I am Professor Orithro De. I will be your instructor for the whole course. In this segment, we are going to introduce microwave. But before discussing microwave, let us discuss the different frequency ranges. They are high frequency or HF, which ranges from 0.003 to 0.03 GHz. Next is very high frequency or VHF, range from 0.03 to 0.3 GHz. Next frequency range is ultra high frequency, which is from 0.3 to 1 GHz. Fourth one is L band, ranges from 1 to 2 GHz. Next frequency band is S band, which is 2 to 4 GHz. Next C band, which is 4 to 8 GHz. Next one X band, which ranges from 8 to 12 GHz. Next one KU, which is 12 to 18 GHz. Then K band, which is 18 to 27 GHz. Then KA band, which is 27 to 40 GHz. Next one millimeter range frequency, which is 40 to 300 GHz. Last one is sub-millimeter range, which is 300 GHz above. Now obviously question is, which frequency range is microwave? The microwave frequency range is from 1 to 10 to the power 6 GHz. And already you are aware that wavelength lambda is equal to C by F from your class 12 conception, which is in case of microwave 10 centimeter to 1 centimeter. Then why the subject is microwave? Because the wavelength is in the range of micro. That's why the subject is microwave. Now let us discuss the history of the microwave, and then we will going to discuss the application of different frequency ranges. Microwave term started in the year 1845 when Michael Faraday observed that a magnet can affect the polarization of light. In 1865, Maxwell derived his famous equation. Can you remember or tell me what are the Maxwell equation? Well, that we will discuss later. But the very famous Maxwell's equation is curl cross H is equal to J plus del D del T. We will discuss in brief in our later lecture. In 1893, Heinrich Hertz proved the Maxwell equation by using one parabolic antenna, where he observed a spark at the end of the parabolic antenna when a current was flown through this parabolic antenna. In 1895, one Bengali, Acharya Jagadish Chandra Bose, derived the waveguide theory, and in 1899 he derived the property of hollow waveguide. It is said that he is 150 years ahead than his time, and at that time he derived the 5th generation wireless communication. Now we are going to discuss the application of different frequency ranges. When the wavelength is in the order of 10 to the power minus 3, there is a direct path between the transmitter and the receiver, or there may be an indirect path between the transmitter and the receiver. When there is a direct path between the transmitter and the receiver, it is known as line of sight or LOS. And whenever there is indirect path between the transmitter and the receiver, it is known as non-line of sight or NLOS. When the wavelength is in the order of 10 to the power minus 2, This frequency range can be applied as an satellite communication or in wireless communication. When the frequency range is in the order of 10 to the power minus 5, it can be applied as a broadband, where the information is transmitted from transmitter to the receiver through total internal reflection. And when the wavelength is in the order of 10 to the power minus 8, it is known as ultraviolet, which can be used for sauna bath. When the wavelength is 10 to the power minus 10, it is X-ray. Obviously, X-ray has huge application in medical science. And when the wavelengths are in the range of 10 to the power minus 10, 10 to the power minus 12, that is gamma ray, or 10 to the power minus 6, that is ultraviolet ray, it is very dangerous for the human body. It can burn your cell. It can cause the cell mutation. So it can cause the death at that high frequency. So whenever you are trying to using this high frequency, you have to very careful. So welcome to the world of the microwaves. In our next lecture, we are going to discuss the waveguide and the other components of the microwave. That's all for this segment. Thank you, students. Bye.